This is the CBU-ASD. It can only be used in countries which use 220 to 240 volts AC electricity, so it's not suitable for North America or Canada. It can be configured to control DALI LED drivers, 0 or 1 to 10 volt LED drivers. It can be configured as push button input, or it can be configured to act purely as a Casambi enabled relay switch, which would allow you to turn off some sort of 230 volt household device, for example. That's something we'll cover in a later video. Various profiles can be used for this device depending on the type of load that you want to control. So for example, DALI broadcast, multi-channel white, tunable white, or RGB. The device itself is powered from 220 to 240 volts input. The output here must only be used when connecting a relay. You must not power the LED driver from this output. This section is the analog digital input. It's used as the control wires for controlling DALI drivers and 0 or 1 to 10 volt drivers. Additionally, you can also connect a push button to this port. This is an example of a DALI driver connected to a CBU-ASD. The CBU-ASD has its own power in source, and the DALI driver has its own power source. The DALI commands are then going via the small cables to the DALI port on the driver and on the ASD. The output port of the ASD is not being used to power the LED driver and should not be. This shows an example of an LED driver and a Casambi ASD which have been incorrectly wired. The LED driver is taking its power directly from the ASD, which it should not do. If this was to be powered on, it would eventually damage the ASD. This is a very quick example of how the Casambi CBU-ASD should be configured to be used as a push button. This is a regular push button, momentary push button, and it's configured to the analog digital ports of the CBU-ASD. Although here the wires are shown as blue and brown, representing line and neutral, there isn't actually any current going through them. It's simply connecting the circuit. Here we have the Casambi CBU-TED trailing edge dimmer. There are two versions of this. On the left is the older version. On the right is the new version. The new version on the right was released in spring 2019. The way to identify the two different versions are: the new version contains the text CBU-TED and trailing edge dimmer on the top, along with the maximum output. The other way to identify them: the older version has a very slight flange on the lower side. The new version doesn't have a flange. There are some slight differences between the two, although they have the same inputs. Line and neutral input with a neutral and load out. Likewise, line and neutral input, neutral and load out. The previous TED could output up to 50 watts maximum with up to 2 luminaires attached. The new one is available in the US or Northern America and in Europe. There are two different variants for the new version. In Europe, it can output up to 150 watts, and there are no limitations as to how many luminaires can be attached to a single TED, but you do need to bear in mind the inrush current. See more about that at the installation guide on Casambi's website. For the US market, it can output up to 75 watts. So again, 150 watts in Europe, 75 watts in Northern America. The type of load that you can attach to these are things like dimmable LED drivers or incandescent or tungsten bulbs, things like that. There are two types of dimming curve available for the TED, a logarithmic and linear, and they can be changed in the Casambi app. There's a third option available which allows the TED to be used as a presence sensor, and that's something we'll talk about later on in a separate video. So as you can see, it's very simple to set up the CBU-TED. Mains power in on the left, output power on the right to your load. This is the CBU PWM4. It can be powered by a 12 to 24 volt DC power supply, and it's designed to power low voltage LED lights, or predominantly LED strip. It can be controlled, or it can control up to 4 channels, meaning 1 to 4 channel multi-dim, tunable white, RGB or RGB white, using the 4-channel output. There are actually 2 variations of this device, one for Europe, which is the device you can see now, and there's also another variant for North America. The difference between the two is the output. For the European model, which you can see here, the power output is 144 watts at 24 volts and 72 watts at 12 volts. For North America and Canada, the output is 96 watts at 24 volts and 48 watts at 12 volts. So the length of the LED strip which you want to attach to this device depends on how many watts per meter your LED strip will use. In Europe, for example, if powering the device from a 12 volt power supply, if your strip uses 14 watts per meter, then the maximum amount of that particular LED strip you could use with this device would be 5 meters. This is a quick example of a PWM4 which has been set up and or connected to and configured to be used with an RGB LED. So voltage in from the black wire into the plus terminal. Output 1 is for red, output 2 is for green, output 3 is for blue. This is the CBU-DCS. It's pretty much a passive version of the CBU-ASD which you've just seen. So it requires its own power supply. Casambi originally designed this to be used with the Philips Advanced Titanium SR LED drivers, and also the any Osram drivers which use the Dexel technology. It can, however, be also powered by a DALI power supply. The device itself requires 5 milliamps when powered on and idle, and can take up to 30 milliamps at peak current. It's also possible to connect a DALI sensor to this device, which I'll show in the next example. This is an example of a Casambi CBU-DCS. A DALI power supply is powered by mains input. That then supplies DALI power to the DCS device. The DCS device then supplies power to the DALI sensor. This is the CBU-ASR. It's predominantly meant for the Northern American market. It can be powered by a 12 to 24 volt DC power supply, and it can control 2 0 to 10 channels with a return input for your minus, also a relay port option if you intend to use 1 to 10 voltage, and a daylight and a presence sensor input port. This is a quick example of ASR used with a 0 to 10 volt LED driver and a 12 volt passive infrared sensor. The LED driver has its own mains input, and it takes 0 to 10 voltage input or control input from channel 1 of the ASR, and it also uses a return channel or return port. This 12 volt power supply supplies power to the 12 volt passive infrared sensor and also to the CBU-ASR. The sensor then supplies a signal to the sensor input of the ASR. And in order to use this sensor input, you need to change the fixture profile of the ASR to the presence profile. This is the Casambi Express switch. It's battery powered. It has 4 configurable buttons for either scenes, groups, single luminaires, and some other things which I'll show you later on. You can also dim a scene, a group, or luminaire using the plus and minus. And the up, down, and down arrow are reserved for tunable white luminaires.